Welcome back. In this lesson, we're going to look at how water can affect the ground. So the geological effect of water. Pure water doesn't really have any effect on most minerals. Most minerals will not dissolve in water. They would possibly dissolve in some acid. And the case that carbon dioxide makes with water in the air is that it can form a very diluted form of acid called carbonic acid. So when it rains, there's a tiny, tiny amount of acid in that rainwater. Now, it's not going to burn you if it falls on you, but when it percolates into the ground and hits any kind of a carbonate mineral, such as limestone, then it can have an effect on that limestone. It can actually dissolve that mineral. Any of the limestone that's now the substrate of the earth, the component of the ground, it could then be dissolved away. And so underground, that water that's percolating down through the water table can have effect on limestone and create little voids, little chambers. Eventually, depending on how much limestone is all together and how much water over how much time, you can get the formation of caverns. So a cavern, we think of it as a cave, but a cavern is an underground chamber. So like a room, sometimes an enormous room, sometimes a beautiful room, underground. These can also form what are called sinkholes. Okay, so where the ground is simply unstable because the rock that's making up that ground is being eaten away by the acid in the rainwater. So you're going to have what is called a karst typography, which is the region of land normally with limestone. You see a lot of this in Kentucky, very, very huge caves in Kentucky, and also lots of sinkholes. And the sinkholes can do a lot of damage if, like, it's under the Corvette Museum and all of the Corvettes fall into the sinkhole, which happened a couple years ago. So you'll see that this water can have a lot of effect. So as I mentioned, carbonic acid is in rainwater because carbon dioxide is a gas and it's in the air, along with water vapor, which is a gas in the air, and they can have a chemical reaction in the air and then come down with the rainwater. You can have some carbon dioxide in the ground itself. So if anything is decaying, you have leaves that are under the trees and they're decaying, they're going to let off carbon dioxide gas as well. And it is possible that as water, if groundwater, can react with that carbon dioxide to form carbonic acid even in the ground. So you're going to have a couple different sources of it. And limestone is that type of carbonate rock that's very susceptible to acid. Even very dilute, which is lots and lots of water and a little bit of acid, is enough to have an effect. They bubble and material kind of just falls apart. It dissolves. Imagine putting salt in some water. That's essentially what could happen. It's happening much slower in the case of limestone being degraded by this carbonic acid, but it's still occurring. And it can form caverns. Now, sometimes I call them caves. They're not. A cave is when you have a mouth in an opening into the side of a hill, and caves can be formed by various regions. You can have a cave that once was a cavern, and a cavern is an open chamber under the ground. And normally, because it's been eaten away by this carbonic acid, you can have sinkholes, which you can kind of understand is you had rocks in the ground, the rocks kind of break apart, and now it's unstable, and the ground above it falls in, and that's a sinkhole. Karst landscapes has a lot to do with imagine that over a long period of time, these caverns do collapse, and then you have deep valleys that once were caverns all over the place with kind of towers left over by whatever didn't get eaten up. So the sides of these caves kind of end up as towers. Some of the real pointy, Chinese-y looking mountains are karst mountains. In fact, you can find karst landscapes all over the world. But we do have them in Appalachia. They are here. There are sinkholes all over the place. And particularly in Kentucky and south of Kentucky in the United States has a lot of these limestone rock beds. So caverns normally are formed in the water table. So if you were to have water in the water table, so imagine in the well, at the bottom of the well, and that well water is in limestone. So limestone is not, doesn't block the water. It can seep through the water, or through the limestone. It's permeable to the water, and so the water can kind of sit inside that limestone. It's a sedimentary rock. But if it has acid in it, it's sitting there. The water is acidic and eating away the rock. So that happens a lot of times. And the load, the limestone solvent that, or the solute that's dissolved in the water, the part that used to be the limestone rock, is then taken away as water is able to get away. Now sometimes that water can't get away. There's not a river there. It's just a blocked chamber of water that's eating away at the cave. If that would eventually form a stream or find a way out, and water usually does find a way out, then it can carry that load away from the cave, and then the cave is empty. So sometimes caves are underwater. You have underwater caves, and then if the water table lowers for some reason, then you can have caves that you could explore, where you could have charge people admission to come to your cave. The ceilings of caverns and the walls of caverns are usually amazing because the dissolved calcium carbonate that's being dissolved by the acid can form icicles. So what looks like icicles are flowing kind of like Niagara Falls-y kind of things on the sides of the walls, where this material is oozing because of the water, but it has minerals dissolved in it. It has the calcium carbonate dissolved in it, and many times it can be left, and you end up with these deposits. And so stalactites come from the top, tights and top, I remember. So you can form these icicles hanging from the ceiling. Then as they drip onto the floor, this dripstone drips onto the floor. It has the calcium carbonate in it and can reform a rock, because it has everything it needs to reform the rock. It has the positive and the negative calcium carbonate, and it can reform on the floor, and you can have these things on the floor, these blobs, called stalagmites, and then they can actually form a tower or a column as if they were to meet. They can also kind of flow down the sides of the walls, and that's called flowstone. So here's a drop of water with the calcium carbonate in it on the left, and it looks like an icicle, but that's not ice. That's actually a mineral, calcium mineral. And then you can see on the right picture, you can have the pointy things from the ceiling, the stalactites, and then the blobby things on the floor. As it's dripped onto the floor, you have these kind of a Dr. Seussy looking things called stalagmites. And then they can join together eventually and form columns. So if you have areas that have acidic water and lots of water in the water table, so where do you have lots of rain? That's normally where you're going to get karst topography. So say in Kentucky, in the Kentucky Valley, water is continuously being brought from the Gulf of Mexico right up the Kentucky Valley to the Tennessee Valley and through to the Ohio Valley to us. And you're going to get this rainwater that has acid in it, and that acid can eat away at these limestones. So you need two things. You have to have limestone structure under the ground, and you have to have lots and lots of water. It can't be a desert. It can't be semi-arid where you're not going to have lots of groundwater. You have to have lots of groundwater, and those two things together will give you karst. And karst is, and remember, the topography simply means highs and lows, so hills and valleys and whatever, caused by this erosion, this chemical erosion or chemical weathering of limestone rocks. So here's a picture of karst topography. You're going to see that as the water sinks into this limestone substrate, then little by little by little, the acid in the water or the acid in the ground can eat away at the stone. and then form these chambers. These chambers then are mostly full of water, but eventually as the water table drops, you can have caverns, and so you can have these beautiful cave systems that you've maybe visited, and then you can have springs coming out. You can have sinkholes all over the place, and this is called karst typography. So sinkholes are bad if they're under your ground, under your house, or under your car museum, and can sink, and sometimes 50 feet deep, because whatever once was this chamber is now the floor, and so you end up with nothing above it. The ceiling caves in these caverns, and that's what it is. On the right, this is a picture, I believe this is in China, and very idyllic looking, but what's happened, these were the columns left over when the caverns caved in. So this little farm is on what was the floor once of a cavern.